Okay. Let me go ahead and share my screen. Okay. So just in case you didn't, there's a link to some formulas which might be helpful, right? That's been there for a while. Also, the first quiz is not for a little while, but it will cover SID, which was our first lecture. Believe it or not, this is only our second actual lecture because of all the holidays and calendar and all that. So it feels weird, you know, it feels like the semester started like a month ago, but. And that because the first one was on, yeah, I was not feeling well, I think. And then yesterday, my daughter was in the ER, so that was fun. So lecture quiz will be on only the first 2 weeks, right? So that includes SID, OID, and alignment. We have another class. This is not going to be on the test, but the quiz will be the following week on March 5th. All right, I'll remind you again. And the quiz will be online on Brightspace, but here, right? So bring your devices, make sure everything's all charged and working. The reason I gave the extra credit, which if you didn't do, there's a brief quiz. I don't care if you get a couple of questions wrong. Everyone gets 5 points if they do it. But my reason for doing that was not just to give a little extra credit, but also to make sure that no one will be able to say, I don't know how Brightspace works. I've never used Brightspace for testing. I had technical issues and all of that. Brightspace for testing is new to me. I did plenty of Blackboard testing, you know, especially during COVID. So I know how that works, but setting it up is a little bit different in Brightspace. So hopefully everything works. Yes.
Will we also be operating with a laptop router? Because that's really computer.
I think so. Yeah. I mean, oh,
Is from time to time.
I think, I don't know, maybe I'm gonna check. Maybe I can turn that off. Because if I walk around, I can see who's naughty and who's nice. If it's a literal test where you guys are home, that's a better reason for lockdown browsing. For many years, there was no lockdown anything, you know. All I did was give tests and walk around with scan, which I still prefer, but like where our Scantron budget is deteriorating. All right, let me test it. So I don't know what other professors do, but I allow you to backtrack. So you can go to whatever quiz you want. I'm sorry, whatever question you want when you want. I also allow, try not to use this, but I also allow, like, if there's a technical issue and you get bumped out, you can go back in.
Okay.
Once. I didn't set it like, you know, indefinitely, right? I don't know how many you put. You can put more than 2, but I put 2. So if you do have a problem, you should be okay, right? That makes my life easier, actually, because if I don't do that, then I have to go. I don't even know how it works with Brightspace. So with Blackboard, I would have to go back in and like give the person like permission, but I didn't even know that was happening until like I was, you know, saw it pop up in my email, like, hey, help, kind of things, and it was that. So once that happened a couple of times, I started allowing people to go back, you know, once or twice. So hopefully it'll be okay.
But when you say go back, you mean, for example, you're taking a quiz and you want to go back to a question, could you do that?
Yes.
Okay.
Yeah, you could go back to a question, and if, let's say you're halfway into the test and your internet connection dies, you could get back in and restart the test. I don't know if it keeps what you've already done or not,
Okay.
but you could definitely start over.
Is it exactly like where we get all the
Kind of, yes.
we're gonna do all the questions on one page?
It's like, I think so, because it's.
I don't remember. Like I actually did it, I think in August, not August, whatever, January, like a while ago. Hopefully, is there a preference to whether you see them all at the same time or not?
Yes, I like that.
What's better? Oh, all at the same time?
Yes.
You don't have to go back up and to like.
And you.
Back-
Yeah.
All right, I think I can change that.
You can't do that.
Oh.
No training.
No, I think I allow backtracking, but all at the same time, they're two different things, right? Yeah.
Yeah,
All the questions came up at the same time. That's the way you prefer. it.
Yeah.
All right, yeah, I can make that change
Yes.
if it's not already done, I might have already set it up. Because the way I see it is if I was here and it was hand drawing and I gave you the test, you have all the questions. So I don't, well, everyone is just, does different things, right?
No. But you mean here.
I mean, I don't really care, so basically.
Yeah.
And then,
We're putting.
but we have a blank date, right?
Like if you don't.
But that costs money.
What if?
No. Yeah, you can bring in one piece of scrap paper, as long as it doesn't have anything on it. I don't know. There is a little bit, right? Because last week we went over, or whatever, not last week, whatever, our first class. Two big calculations are inverse square law and direct square law. And that's basically the reason you take MAT 1275, so we know everyone can at least cross multiply. Really? Because there isn't a whole lot of math in the other classes, right? And inverse square law and ratios and a few little, they only seem to show up in my class. But I guess you have to take some kind of math to get an associate's degree, whatever it is.
For you.
So that's been in existence forever. What else? So that's all I have to say about the quiz. I'll make sure that you can backtrack and see the questions at the same time. I'm just hoping it all works because I combine the two sections. So like I don't have a separate Blackboard for a separate, excuse me, I used to do this with Blackboard also and combine the two sections. And what I would have to do when it came to a test is I'd have to give one entire section an excuse to take it at a different time. That was the way I was able to, like, rather than literally creating two exams and putting it into two different bright spaces or two different Blackboards. I just hope it works. But we'll see. Don't worry, whatever happens, you know, you won't be penalized for it.
The first quiz is just the first three chapters.
It's like I said, it's SID, OID, which I just delivered, and alignment. Okay, so we're still recording, right? Okay, so let me get rid of that. And we are doing alignment and motion. Okay, so hopefully everyone's been doing okay at clinics. We had some pretty good discussions in the last class. You know, about fall prevention and putting the patient on the table instead of trying to do everything on the stretcher, with backfires most of the time. Especially if you have to make a change. It's hard to get, like, I think it's easier to get the patient on the table with help than it is to try to get the flat panel detector underneath someone on the stretcher and make sure everything's aligned and everything. And then if you have to repeat, well, then it's just as hard because then you have to put it under again and move things around. It might seem like you're saving time before the case even starts, but it's probably better to invest a little bit of time getting the patient on the table, because then if you do have to repeat, it's just moving things, you know, table floats or moves around, and it's easier. So I'm a big fan of getting the patient on the table, even though it seems harder at first. It probably pays off in the end, to be honest with you. So we talked about that, and we talked about, you know, one of the things I do on the side is, you know, expert witness stuff. And my first job to do is like, try to, usually when it's malpractice, and I take the patient side. I don't always take the patient side, but I look to discredit the tech, right? So I had one case involving fall prevention. And, you know, the question was, did the patient have the band? Because if the patient doesn't have the band, then you can't fully blame the technologist. But if the patient had a band, then you could say, this is not this is, you know, against our scope of practice, and this probably should have been done in an alternative way with the patient sitting down, either in a wheelchair or a stretcher or whatever. But I know that for some reason, a lot of technologists will stand the patient up anyway. They'll just say to the patient, can you stand? And the patient will say yes. And it doesn't matter whether they came in a stretcher or a wheelchair. If the patient says yes, a lot of technologists will stand them up anyway. I think this is a bad idea, especially if the patient falls, which hardly ever happens and may not happen in your entire career. But across the country, it happens here and there. And then they call me and they ask for my sort of professional opinion, right? And my first thing to do is like, is this person licensed? And, you know, was there an actual ban? Was there not? You know, so try not to get yourself in trouble. I would ask the technologists, you know, they have a full prevention ban. Should we be standing this patient up? What's the hospital or radiology protocol, right? You know, you kind of have to protect yourselves a little bit. Now, as students, right, everything defaults to the technologist anyway. So if anyone's going to probably get in trouble, it's the technologist. But still, you know, you will be technologists. That's the whole goal of the program. So, you know, keep that in the back of your head, right? Interesting case I have right now is CT tech. So I go after them too. CT tech injected, there was extravasation, right, where they weren't in the vein, so not here, and like their arm like puffed up. And usually, you know, not necessarily the technologist's fault. Sometimes things happen, and patients do sign consents. And but in this case, very rare, the contrast infiltrated the bicep, and the bicep tore and actually needed surgical repair. So in that case, I looked to see if the technologist was licensed, not in this state, different state. I looked to see if they require IV certification, which they don't in Florida. So that wasn't something I could go after. But it turns out they probably don't have much of a case anyway in malpractice, because that's super duper rare, right? It's like 0.3 of 1%, something really, really low, right? And I have to tell them shit happens. So just pay me and don't take the case. Yeah, I get calls for like the weirder stuff. A lot of them are falls. You know, one was a I go after them too. One was a nuclear medicine tech who put a patient on the table, had done many times, and the patient weight limit exceeded the table limit, and the table broke, and they hurt themselves. I think they won on that. I actually got called to court for that, which hardly ever happens. So I had to sit on the stand and travel, but you know, I charged them for everything. So
That's all.
Yeah.
So is there no way the requisition form talks about the weight of the patient and see if the patient is overweight, so you can put them on the table, because some tables can check them.
So, okay, this one was a little bit nuanced because the table had a weight limit on one side versus the other. It was a little weird. It wasn't as you know, but it was almost, I mean, basically that's the way it was. And you know, generally speaking, you have more weight from here up than like your legs. And that was the part that was exceeded. you know, it's hard to say where the weight was exactly coming from, but this guy was like 6'2" or 3. And he was a big dude. Anyway. So be careful. Try not to make any money for me. It's okay. Someone's falling somewhere or something's happening somewhere. Me? Well, it depends. So the nuclear medicine tables are different than the X-ray tables. X-ray tables take a lot more, but there are even limits on the X-ray tables. It depends on the type of table. But if the table has a written thing on it, which some of them do, trust me, now every time I like go to places, I'm looking for stuff that, you know, you wouldn't normally think about. Yeah, but you could exceed the weight limit on these tables. I have another case that might happen, I don't know. It's kind of funny, and I'll start the lecture right after this. So I work through like a headhunter. So what they do is like, let's say you're a lawyer and you need an expert. You go to this company and you're like, I need an expert X-ray tech. and then they reach out to me or other people. But when they do that, they can't give you too many details of the case, right? Because you haven't, it's not until the lawyer meets you, talks to you, and then decides, yes, we'll hire you, that you get like the real information. And then you get like a ridiculous amount of information. But at first you get this email that's like, so I just had this email. What happened? It was an MRI case, and someone got hurt inside the MRI machine, something like that. Would you be interested in discussing this further? So, yeah, of course, right? And I'm still trying to figure out what it was. They haven't called me yet. This could be a projectile of sorts, or I'm not really sure, but they don't give you a whole lot of information, like especially in the initial email, right? Maybe you get some more information after you talk to them, and then you kind of decide what's going on. But every modality has its own like world of safety for different things, right? Depending on what it is, right? So be careful out there, because stuff does happen, and even if it never seems to ever happen, and if the technologist's been working 20 years and said, well, I always stand up patients and nothing has ever happened, you never know what could happen the next day, right? So, you know, previous results do not mean future results will be the same. I've actually used some line to that effect. It's like stocks. Like I was thinking of buying Tesla stock, but you know, and it was great until recently. It's been going down. So, okay, so let's talk alignment and shape distortion. This should be mostly a review, right? So what we don't want to have happen, to the best of our ability, is shape distortion, right? We don't want the shape changing because that can cause a misdiagnosis, make it more difficult for some future surgical procedure, let's say, or let's say a prosthesis. So we worry about things like this. But when it does come to shape distortion and angling the beam, sometimes we angle the beam on purpose, as you know, to remove superimposition or maybe see something better. So unlike OID, which is never good to have, right, because it creates magnification and reduces spatial resolution, sometimes we create shape distortion or angle the tube on purpose, right? So that's kind of what we're going to be talking about today, right? So the example that I use a lot is on a lateral knee, and everyone seems to do lateral knees differently. I don't know if you've been there long enough to work with different techs. Some people just turn the patient on their side. Some people turn the patient like fully on their side and then bring the affected knee behind the other one, which is the way I do it. It comes out better. But you can add 5 to 7 degrees, right, to try to superimpose the lateral condyles, right? That's how you know you have a good lateral, right? So that's using an angle on the tube that normally is something we don't like to do to actually help you achieve what Merrill's and the competitor to Merrill's, which is Bontrager, will say, right? So when you off center, that's the same physics as angling, right? The reason why we have a central ray is because we want to put it to the most important area of the body to create the least distortion, because that's the area that will have the least divergence. Remember, the X-ray are divergent. But if your alignment is not good, those divergent beams are coming out at angles. So by off-centering, it's as if you angled the tube, right? So that's why we have to pay attention to where the central ray goes. I mean, I admit sometimes the central ray is just mid-forearm. You know, it's not as accurate as third metacarpal phalange joint in your hand, right? It's just like mid, wherever. But a lot of times it's designed to reduce distortion, right? So that your angle is where you have the least amount of distortion, where the central ray theoretically is. But you're going to get a few degrees of angling, even if you don't angle, just by having your alignment off, right? And we'll give you the numbers on that in just a second, because it depends on whether you are at 40 inches SID or whether you're at 72. So when possible, the golden rule is to try to make sure that the part is parallel with the image receptor. So if you're doing a forearm or an elbow, right, you're out like this, and it's parallel to the image receptor. But we do have to be, well, the other thing is the tube should be perpendicular, right? So not angled when we can. Thicker objects, unfortunately, you don't have a choice of what you're X-raying, but thicker objects, especially spherical objects, like skull, like shoulder, like head of the humerus, like head of the femur, those are all sort of circular, spherical. Those are going to show more distortion than a bone that's more flat. So flatter bones have less distortion, like the scapula, like the pelvis, at least the part of the pelvis before you get to like the wings that kind of curve in. But again, you can't pick, and there are some sort of general things to kind of keep in mind. So if the object is flat or sort of tubular, if they're at least parallel to the image receptor, like I said, they're not going to get as distorted, right? So this is a nice flat object. And you can see even with this angle that we're not getting the magnification, right, that we normally would on really almost anything else, right? Now, foreshortening is probably worse than elongation, because sometimes when we angle, we create elongation, and people do that on purpose every once in a while, like I was just saying. Foreshortening, we're never trying to foreshorten something. That's never a goal. So this will happen if the object is at an angle instead of parallel to the image receptor, like in this case. And, if we are to believe the book here, right, I don't know what angle this is at. It's pretty steep, right? Good example of this, though, would be the patient that can't extend their arm. because they messed up their elbow somehow, so they can't do this, they're like stuck here. Right, but that foreshortens makes the object smaller, and in this case, cut it in half. We try really hard in radiology to have these standards so that people, when they look at a radiograph, will know if something is actually bigger or smaller than what it's supposed to be, right? That's why we have things at 40 or 72. That's why we do things PA versus AP or AP versus PA, whatever it might be, to try to reduce all those types of distortion, shape, size. And sometimes we can't, right? Things are what they are, right? You place the body supine, the actual bones inside are not all going to be parallel to the table, right? Things within the body are at different angles. So you can't necessarily get things the way you want them perfectly, right? And we're not going to hang someone from the ceiling and put them at some weird angle just so we can try to make something parallel. That kind of takes too long and not so nice. But foreshortening happens, and we don't want things to look either bigger or smaller than they are, right? Because if you're going to put a prosthesis into someone, you want it to have the exact measurements, right? They're getting pretty good at like 3D printing stuff now and trying to customize things perfectly to patients, which is really nice, right? Because you don't want patients to like walk with a limp or something if they didn't get the thing right. But you can fix that, just, make a bigger heel on one side or something. No, you shouldn't really do that, right? That's not the way it's supposed to work. Oh, we'll just fix that by giving you like, an extra inch on your right heel of whatever shoe you buy. Right. Personally, I'd rather have that than surgery, maybe. I mean, I could deal with that if I had to. So check this one out. This is pretty interesting. So the IR is parallel to the table, which it is most of the time, especially if you're using debulking. I mean, what else would it be? Right. But if the center ray is angled, you can get devastating results here, right? I mean, 1.5 centimeter is the actual object, and it's like 3 times that on the image. Does that mean like the tumor or the pathology or whatever it is going to look worse? And maybe that person, instead of doing radiation, automatically goes for surgery to get out as much as they can? You never know. So this looks sort of like an extreme case. And as you'll see from the previous lecture, some of the examples are, we were talking about OID. And the question is like, oh, you have an OID of 20 inches. Like, when in reality do you ever have an OID of 20 inches? Do you levitate patients? So a lot of the stuff you see in the book is theory, and they're not going to give you small little examples, but technically an inch of OID will do something, and 20 inches will do obviously a lot more. But I think at the end, it'll make you better technologists because you'll absorb a little bit of this. You won't be thinking about it every day, right, when you're taking x-rays, but it's there and you get something from it, I hope. So this is an interesting one, and we do this lab. So this is one of my favorite labs. Did we do this last year with the coin? And I had like 7 different pictures. Yeah, I think we did this one already, which is pretty cool. So this is the actual lecture that went with that lab, where if you have an object in the body that already has a very different layout such that when you lay the patient flat, you're still never going to get the part even remotely close to being parallel with the image receptor. So, unless you were somehow able to like dangle the patient, again, that's not realistic. But Szynski's law of isometry, which obviously I don't think about every day, says that instead of getting this foreshortening, just based on nothing you did, but the part inside, is at an angle to the image receptor such that it automatically is going to look foreshortened if you don't do something. Right? It's just nothing, it's out of your control, really. But what you can do, right, is you can use what's known as an isometric angle. So the isometric angle is based on what angle there is with the image receptor and the sacrum, which happens to be around 30. So that you can kind of take as your number for most average patients. So you just have to, unfortunately, assume that's what it is, right? Is it going to be a little bit different between patients? Probably. And taking an isometric angle says you take half of that angle, which would be 15, and you place that 15 degrees onto the tube. And that will help remove the distortion. And it pretty much worked. If you remember the lab, A, which was the baseline image, where the coin was parallel, there was no OID, the tube was perpendicular, everything was perfect. Yet B, C, and D are different. But E was able to compensate even when the coin was at 45 degrees. So the coin was at 45 degrees. Remember, you had to tape it to the sponge and everything. But we were able to get rid of the distortion by placing an angle half that. So yes, I know you couldn't exactly get 22.5 degrees on the tube, but we were able to get close enough that E looks a lot like A, even though it was at a 45-degree angle. So this was a really good lab because it actually worked, for one. So I like labs that work. And I like labs that are pretty dramatic, because if you looked at E prior to the actual radiograph, you know, again, it was up at this angle and looked all wrong, right? But that's the way the sacrum is in your body, right? So I just kind of thought that was pretty cool. Now, if the sacrum or another object is spherical, then you have a problem, right? So when objects are kind of flat or tubular, things work out better. But you can't really fix distortion on a spherical object. It's very difficult, because no matter how you angle the tube, you're tangentially skimming the object no matter which way you turn it, because it's a sphere. So there's only so much you can do here, right? So objects that are round, that are spherical, they don't have this long axis the way the scapula, the way the sacrum, and the way a lot of other parts of the body are. So where this comes into play most often is skull, head of humerus, head of femur. They show a lot of distortion, right? Even when you don't angle, right? So they're never quite that good, and they get even worse with like a little bit of angle. So elongation distortion will occur anytime a spherical object is projected with an angled central ray. So as soon as you angle, things get bad, right? And here's the problem. You may not be angling the tube, right? But the patient's head of the femur, they come in at angles. So again, this is something you can't control when you put the patient supine. Could you imagine how much worse it would be if for every object we did, you had to think about all the things that you currently have to think about, but then try to get the object as parallel as possible? You know, can you imagine? I mean, I guess it could be done if you kind of write down yet on all the positions would get like exponentially more difficult, right? If you had to like do something weird and like get a protractor out every time you tried to position someone based on the actual part and where it literally lines up with the image receptor. That would be tough, right? Suppose you could try with certain things. maybe like mini obliques or, you know.
So, a quick one, so you're saying, a spherical object, probably not, but is it like, because it's a more magnified image, like the head of the humerus, so does it magnify the image or it just shape distortion?
It gives you a lot of shape distortion, you know, the shoulder. You can get the patient, you know, back against the image receptor, and you can turn them internally or externally, depending on the tuberosity that you're looking for. But the shoulder itself comes in at a certain degree compared to the rest of the body that isn't going to be exactly parallel to the image receptor, right? And that happens more, right? That type of distortion happens to happen more in spherical objects than flat objects. That's the point of the last few slides. So what you have here, right, are good examples of this, right? Image F projects the head of the femur with a CR, central ray, perpendicular to the image receptor for comparison. G has elongation when the central ray was angled 30 degrees. Right, we're getting a bad image, and I see this all the time. Right, but what I'm saying is, it isn't always the central ray, right? Sometimes it's just the positioning of the patient, right? Especially when you try to do things on the stretcher instead of the table or the upright, because you're trying to cut corners. Sometimes it gets foreshortened, like G, such that you can't see the fraction, right? It's hard to see in the neck, which is a common place for the femur fracture to be. I've seen some pretty bad ones, right? I've seen some ones where I call it the scoop is off the cone, right? Like the whole head of the femur is actually separate, right? Kind of like the ice cream coming off the cone.
So G is foreshortened.
G is, yeah.
So is
Oh,
it,
here's a little.
is it
Yeah,
elongated,
this is
elongated with the head of the humor? This is elongated, but the
Yeah, to me, this looks foreshortened,
elongated.
but I mean, I could double check everything for you. According to the book, it says elongated, you know, which, you know, it technically this should be right, but it doesn't look right. But I will double check for you. I mean, if you have a 30-degree angle, that should cause elongation,
Yeah, because the head.
but it doesn't look stretched out to me.
The head looks shut over that part.
You know, maybe we're not seeing the full, maybe because we're not seeing the full view. Okay, so this is kind of new, right? Everything we've talked about has been, I hope, pretty much a review. So I mentioned earlier that just by being off in your alignment with the central ray, even if you don't place an angle on the tube, you can still get elongation, right? And it works like this. If you're 40 inches SID, right, you're going to get 2 degrees of beam divergence per inch, right? So 1 inch, 2 degrees, 2 inches, 4 degrees. This is as if you angled, let's say, 6 degrees without actually angling if the central ray is 3 inches off from where it should be. Okay. So alignment is important, especially when techs do tricks. So let's say the alignment is off, but the object that you want to see is still on the image receptor, is still viewed on the monitor. So in the past, when you had film, you couldn't hide that. People would see that the alignment was off. And if the radiologist knew that there might be a little bit of elongation, even though the tech didn't turn the tube in any way, they can account for that in their head. where I'm going with this is, let's say now you have that same elongation because the alignment is off. But the alignment doesn't look off because the tech cropped the image. And now it looks perfectly centered on the screen. So there's no visual indication now that there may have been some extra elongation that no one will ever know about. So the techs think. Now, I don't think that would ever turn into some like case that I would get called in and kind of how would I prove that? I wasn't there. That's generally not, we don't write down what we do in every X-ray. Right, we don't write down that the central ray went through the established, that's not part of the notes when you get notes, when you look at the patient's medical record. Right. But technically, it's there. Now, it gets a little better, right? The divergence, instead of being 2 degrees at 40 inches, is only 1 degree at 72 inches. So be prepared for a question from me that says something to the effect is, what is the degree of beam divergence if the alignment is off by 4 inches and they were at 72 inches? Or something like that. I'm not going to ask 10 questions because you only have to memorize one little thing, and then you'll get all of them right, which is the objective. I'm happy when people get questions correct, and I'm happier when people, pass the register. But this is one of those questions that they might ask. But in a way, it does prove why central ray is important.
The radiologist can see when it's off, even though it's.
Sometimes they can, sometimes they can't. And do they have the time to investigate? Probably not. Right? They just pops up on the screen. Do they care if you collimate it or not? Maybe. Sometimes. They probably care more if they don't see any collimation on a baby. But where do they start and where do they stop caring is pretty subjective. And is it enough for them to, speak with the administrator of X-ray department and schedule like a meeting for like all the techs? And, it depends. Like I went to a meeting once. I was the clinical instructor though, and they just invited me because I happened to be there that day. And apparently people weren't using markers like at all. Right. And then one person, took like a paper clip and turned it into an L, which was like pretty lame. So how'd you know I did that one? You're out of here already? Lucky you. I see my students later. Oh, and this Friday's gonna get messed up again because of course Samia called the meeting started to talk about AI, ER, and error, whatever stuff. On Friday. It's a bad. Oh, but bad. Just keeping down stuff. And it hasn't even been 24 hours. But, yeah. Thanks for asking. Okay. And this is a rule of thumb that a lot of people get confused with all the time. So I think we talked a little bit about this in our first or second lab ever, right? Where I pointed out if you angle the tube and then extend your tape measure, you will see that you no longer have 40, but you have more than that. Yeah. And now we also know, maybe not on that first day, but we also know that changes in SID will change magnification. Yes. Right? So to keep that preserved and to keep magnification at a minimum, what should you do when you angle the tube? So there's this sort of rule of thumb that says for every 5 degrees that the central ray is angled, you should bring the tube down approximately an inch. Oh. Right? So if you angle 30 degrees, that's 6 inches. Again, MAT 1275 comes in handy for division as well. So that's a rule of thumb, right? What I usually do is just pull the tape measure and check yourself. It's not that hard. But what would that extra SID do, if anything?
Make it look smaller.
It would make it look smaller, right? Which is just as bad, right? Because if you have some small pathology that maybe the decision is, we're not going to do anything about it, it's so small, right? Might actually be a little bit bigger, it might be more concerning. Who knows, right? Changes in SID relatively don't change the size dramatically enough to even really see it, right? If you remember, we had a hard time measuring in our lab. A change in SID. But theoretically, it's there, right? I don't know, eventually AI is going to be reading a lot of the images, right? And will be used to kind of maybe look at complex cases so that radiologists can focus on like easier stuff. And then eventually maybe they'll just get, they're starting to show more and more studies that the AIs are catching things that the radiologists aren't. Right. So, I mean, all in all, that's good. I would say, right? But right now, the AIs are just sort of helping, like maybe pinpoint things, and then ask what the radiologist thinks. But it's not a long leap before it just doesn't bother asking them, right? And just gets things right most of the time. It'll probably get that way, which might be okay. Radiologists will maybe visit patients more often to try to see things that the AI could never see and help make a better diagnosis by actually seeing what's going on with the patient instead of being locked in like a sort of cave the way they are now. Right. So I don't think radiologists are going away anytime soon. And I don't think AI will replace us either, because most of what we do positioning wise is pretty difficult for, I would think, a robot to do. Right? Like to try to turn a patient into an oblique, or ask a patient to, for an internal oblique elbow, just have them pronate. I don't think the dexterity is there yet. Yeah, there's a lot of, there might, no empathy, huh? For the robots. I mean, it'll be a while. I think it'll be a long time before that happens. I am a little worried about MRI and CAT scan. I do worry about that a little. Because the positioning for those are like lay down, don't move. The rest of the stuff, it does require a higher level than radiography, but it's still mostly automated, right? And mostly adjusting parameters. And I could see computers kind of doing more of that because there's not that much positioning. Right? You don't get 3 semesters of positioning for like MRI.
The gas scan machine actually talks to you during the procedure. And I had it myself a few years ago. The machine was talking to me the whole time.
Like hold your breath?
Yes, all the
Yeah.
instructions, everything.
Yeah, they've been doing that for a while. I wouldn't call that AI. But they do that, and they have it in different languages. And
I wonder for the city, the position is not as complex as radiology, because it's just to put in the patient and use the laser light, and that the major thing is your technique.
yeah, so positioning in CAT scan and MRI is really just kind of lining things up with the mid-sagittal plane or the mid-coronal plane, and it's, if you want to even call that positioning, it's more like just aligning the patient than it is positioning anything really. So it's much easier. So when it comes to like automation and AI, I worry about CT and MRI more than I worry about general radiography. Right? You know, so hopefully I'll be able to deliver an AI lecture to you guys near the end of the semester. I've been working on that one. I might have AI deliver the AI lecture and not even be here. I'm just kidding. But I worry about myself too. I mean, I don't know where teaching will go eventually in terms of, I guess it depends what the subject is, I suppose. And I'm not really worried for radiography either, because there's a lot of dexterity involved in positioning. So I don't think that'll be replaced anytime soon.
My worries on the automobile section, the cars. That's what I worried about.
For which?
I say my worries on the cars. That's why I hate remote cars. Cars that use machine. You don't have. I want to be able to control my stuff.
Well, AI is here. I don't think it's going anywhere. It keeps getting better every day. I have now switched basically from Google to Perplexity for search. It gives you much better answers. And you can kind of ask it questions and it'll give you an answer rather than give you like 20 websites that you have to then pick which one you want to go to and then look at yourself and then decide what's important. It does hallucinate. I'll give you an example. For one of my cases, I was using AI a little bit and looking up distal bicep tears and how often it happens. And it said to me at one point that there was a worldwide study that said, you know, less than 3% of something that this occurs. So my next thing was, give me the citation for this. Tell me where you got this. And then it was like, oh, well, really, I don't have any. So it lies. And it tries to be friendly too. It's politically correct and all that kind of stuff. So you have to be careful, you know, using it for certain things. But, you know, I don't know the radiography Florida law on if there's a license or if there's a separate license for different things. And asking it some basic questions was able to get me directly to certain websites, which I could then research, which I don't know if Google would have gotten me there as fast. Right. So it definitely has its uses, but it lies. It hallucinates, they call it. You know, everyone lies. Not everyone lies. I don't know. Or tries to. All right. Any questions on what we have up here? Well, it's up here. Spherical objects, bad, right? Nothing we can do about them. OID, bad. Alignment, important, right? The further away you are, the more divergent you get. Remember, it's 2 inches of, 2 degrees of, as if the tube was angled for every 1 inch being off central ray alignment. And 1 degree for every 1 inch if you're at 72. Szynski's law says if you have a curved object, that we take the degree of angle that part has with the image receptor, and we place an isometric angle on it, which means half of the angle that the part makes, and you place that on the tube to help reduce distortion. You had a question?
That person needs to be able to have the question on the test, like figure out what angle you need to try to see our.
I might, but that one's like so easy. Because literally, I would have to give you the obliquity, right? And you just cut it in half. I mean, maybe I'll do that. I don't need, all of my questions don't have to be hard, right? It would help me realize that this 3 out of 65 people or whatever, like, didn't get that at all. Maybe they missed that day in class or didn't want the video. But it will probably would improve anything. Some of the concepts, though, from the previous class, I think are important. Because we talked about air gap and having OID and how that can help reduce scatter, right, and improve your contrast. The problem is you also get magnification. So at the end of the day, they'd rather expose someone with a grid, which requires more exposure, to get the same contrast that they could get with no grid and an air gap, so that they could reduce the magnification. So magnification, especially OID, is significant enough to expose the patient to approximately 4 times the radiation. So you have to look at the pros and cons of things when you do certain things, right? It might help you in one area, but be extra detrimental in another area, which is why we don't use the air gap technique that often. The only time, I'll tell you a little story, was one of the best lectures I went to, was a guy that worked in the medical examiner's office, right? So X-raying, dead people, and they didn't complain, and they didn't care about radiation. So he was able to use super air gap techniques, crank up the radiation, got really good images, and it was film at the time, so it was harder to get the best contrast, and you couldn't manipulate it. And if you used a grid, because the grid frequencies were much lower, then you get a grid lines. There were all sorts of problems that he was able to solve, but he would do things like at 100 inches instead of like 72, and he did all sorts of things, which I always thought was interesting, that you couldn't do in real life. You could only basically do on dead people. Yeah, so yeah, that's a field that you can get into, I suppose.
Now with digital, I guess you wouldn't even experiment with that anymore. You could just adjust the post processing.
Yeah, I mean, they're still taking X-rays because, it helps if you have a bullet and at what, they can figure out a lot by where it is in the body and at what angle it is, and then extrapolate from there where that bullet came from and what the angle might have been. There's all sorts of forensic X-ray stuff, which is pretty interesting. I don't even want to deal with regular patients, let alone dead patients anymore, at this point, but, Okay, everyone, I think that's it. So I will put up both videos. Make sure you watch the one that you didn't see this morning, but feel free to watch them both over and over. I'll eventually switch them to YouTube also, because I hate Zoom now. Oh, yes, for next lab we have, we're doing the portable test. Yeah, bring it in.
So we're gonna see it. Yeah.